Hello students, welcome to classroom. In today's class, we will be learning about mirror formula and magnification in detail. Okay, so let us start the class. So the first thing is I'll tell you mirror formula. So mirror formula, okay, this is very important for numericals. So now in the previous class, we have learned about the sign Cartesian. Okay, so there you have been introduced to U, V, F, H, I, H, O. Okay, all these terms have been introduced to you. So using those knowledge, now we move ahead and now we will be making a mirror formula. So how does the mirror formula look like? So the mirror formula is made using U, V, and F. So let us have a look at the mirror formula. So mirror formula is 1 by V plus 1 by U is equal to 1 by F. Okay, that's it. This is mirror formula. Just remember this one. This is very important while solving the numericals. Alright, so basically that is it. Okay, this is the mirror formula. Its application we will use it when we solve numericals. Okay, now next we will talk about magnification. Okay, magnification. So what is magnification? See, the definition of magnification is very simple. Magnification is just ratio of height of image, okay, ratio of height of image to the height of object. This is magnification. Okay, if you have to write the definition, this will be the definition of magnification. Magnification is the ratio of the height of image to the height of the object. Mathematically, how we will write magnification? You will write M, okay, and ratio means division. This is not division, and you will write HI because it's height of the image. Height of the image is HI, okay, and below you write HO. Okay, this is one formula for magnification. Okay, let's make equation 1. All right, you have another formula for magnification. Okay, magnification is also minus V by U. This is another formula for magnification. This is formula number 2. Make it as equation 2. Okay, now look carefully at equation 1 and equation 2. Equation 1, okay, is a formula for magnification. So M is equal to H1 by HO. Okay, this is the left hand side, and on this side we have the right hand side. Okay, second equation, this is again the left hand side, and this is again the right hand side. If you observe equation 1 and equation 2, you will find that the left hand side is same, is not? The left hand side are same. You have M here and you have M here, so both the left hand side are same. Okay, so using logic, that makes both the right hand sides also same. So comparing equation 1 and equation 2, since the left hand side of both the equations are equal, the right hand side should also be equal. So on comparing 1 and 2, so you will write comparing 1 and 2, comma, we get, what do we get? We get a new formula, which is HI divided by HO is equal to minus V by U. This is one formula again. Okay, so these are the formulas, okay, that you have to remember. Okay, the first one is mirror formula, and this formula is called the formula for magnification. This is another formula for magnification. Okay, in the second formula, we find magnification, okay, with the values of image and object. We are dividing the image distance with the object distance. On dividing the image distance with the object distance, we can find magnification. In equation 1, the formula of magnification is we divide the height of the image with the height of the object. Okay, so this is one formula. Magnification has two formula. Combining equation 1 and equation 2, sorry, not combining, comparing equation 1 and equation 2, you will get another formula which will look like this. All right, so now we move to the next one. I'll tell you some more, okay, about magnification, which will be helpful to build your concept. So let me erase this. Magnification is a big topic, so I want you all to be thorough. So let us discuss some concepts again, so that your grip on magnification will be better. Now let us start. So okay, magnification M. Let me write a little big here, M. Now or let us first start with a proper case. So let me erase this again. Now let us draw ray diagrams. Okay, so yes, object. Okay, object, let the object be tall. Let's make the object taller. Okay, so object will be taller. If I make the object taller, then the mirror also has to be taller than in this case. So let's make the mirror also, okay, taller. Okay, the aperture of the mirror should be bigger. So this is the mirror. This is the pole. This is the object. Where should I keep the object so that the object is bigger than the image? Should be behind C. Okay, if it is behind C, then it will be alright. So let's mark the focus. So if I want to keep the object behind C, this has to be my focus. Making sure that it's same, I keep my C here. Alright, then I draw the ray diagram. Ray 1 passes through focus. Ray 2 also passes through focus. Okay, and where does it meet? It meets here. So reflected ray here. This is the incident ray. This is the incident ray. Reflected. This is the reflected ray. Where do they meet? They meet at this point. So this is the image. Right. The object is here. The image is here. Okay. So now let us talk about magnification here. So magnification is height of the image divided by height of the object. Yes or no? Now, so this is HO and this will be HI. Okay. Now it is very clear from the figure that the height of the object is bigger. Okay. So let's say the height of the object, let's take the height of the object to be 20 centimeter. So let's say the height of the object is 20 centimeter. Alright. Now the height of the object is 20 and look at the height of the image. The height of the image is almost half. So can we take this to be 10? Okay, just for calculation. Okay, so let's take the height of the image to be 10. So let's take it to be 10 centimeter. Okay, because it looks like half, nah? So this much only, so it's almost double, nah? The image is almost half of the object. Okay, and the object is almost double of the image. So HI, we are taking here HO value to be 20 centimeter and HI value to be 10 centimeter. Okay, we are using the formula of magnification. We are going to study magnification here. So put the value of HI. HI is how much? 10. HO is how much? 20. Cut. What you're getting? You're getting 1 by 2. 1 by 2. Divide. So 2 divides 1. So too small. Needs help. Put point here. Give him 0. So 5. So 2 5s are 10. 0. So M value. This is M value. M value. You are getting 0.20. 0.5. Okay. We don't write any unit. Magnification is unitless. That means no centimeter, no kilometer, nothing without any unit. Okay. So what did you get? The value of M to be? The value of M you got as 0.5. Now see. So the value of m is 0.5. This is bigger than 1, equal to 1, or smaller than 1. That is the question. Okay, is m bigger than 1? Is m bigger than 1? Is m equal to 1? Or is m less than 1? This is the case. Okay, if the v is, see, the mouth, I call it the mouth. Of course it is not the mouth, but that's how I learned. So the mouth, if the mouth is opening towards wherever the mouth is opening, that value is bigger. Okay, since the mouth is opening towards m is bigger. Okay, like once again, okay, I'm sorry, but then that's how I learned, so I'm more comfortable like that. Okay, here this is equal, there is no, everybody knows that this is equal. Again here, okay, how do you interpret this? Okay, if you ask me, since the mouth is opening towards 1, so I understand that 1 is bigger than m. Okay, so whichever you understand it, but that's how I understand. So so this is in here, this is interpreted as m is bigger than 1. Okay, m is bigger than 1. That means m value can be what? If we take this, if we take m is bigger than 1, okay, if we take this condition, then we can say, since m is bigger than 1, that means the value of m is bigger than 1. That means m can be 2, nah? Because 2 is greater than 1, nah? So we can assume that the value of m is 2. Yes or no? Okay, now if you take m equal to 1, if you take m equal to 1, if you take m equal to 1, if you consider this case, if you think on this case, m is equal to 1, that makes m also 1, isn't it? Are you following? Okay, then if we take this, m is what? What is this? M is greater than 1 or m is less than 1? M is less than 1. Okay, m is less than 1 because the v is facing towards the 1. So m is less than 1. That means the value of m is smaller than 1. So it can be 0.5 or not? Okay, because 0.5 is less than 1, nah? Okay, so this one, the answer that we got, m equals 0.5. Okay, where does it fall? Is it fall under this category? Or does it fall under this category? Does it fall under category 1 or category 2 or category 3? In which category does it fall under? It falls under the category of this one. So it falls under the third category. Okay, m value, which is 0.5, is less than 1. Okay, so here we are getting m value less than 1. Do you follow? Okay, remember here we are getting m value less than 1. All right. Okay, so this case, okay, this case is this case. Okay, here this case falls under this category. Okay, here magnification we are getting us less than 1. Okay, now next next let us see another case. Same. Okay, mirror, concave mirror, only we are taking concave mirror. Then this is the pole. Now here I made the object taller, isn't it? So now let us make the object's size smaller and let's make the image size bigger. Okay, and see what is the case, how it will turn out to be. So let's take the focus here, keeping the curvature here. So which case should it be? In which case is the image larger than the object? Okay, if we keep the object here between C and F, okay, we will get it. So let's keep the object between C and F. So let's keep the object between C and F. So object is kept here between C and F. Ray 1 will go like this. It will pass through focus. Okay, the other ray will go through like this, through focus, and then it will pass through like this. Okay, so here the image is formed here, and you can see that the image is, okay, bigger than the object. Okay, this will work for us. So let's take this one. So formula of m. Okay, so same thing. Okay, let's take this to be 5. Okay, this time let's take it 5. So let's take this to be 5. This is HO. Let's take HO to be 5 centimeter. This is HI. Let's take HI to be, say, 10 centimeter. Okay, so m is equal to HI by HO. So m is equal to HI is then HO is 5. So M is equal to 5 ones are 5, 5 twos are 10. M is equal to 2. We are getting M value as 2. Now, on which case does it fall under? Case 1 or case 2 or case 3? M value is 2. M value is 2. That means see, on which case does it fall under? Where is it? Here, you can see here now. M value we got 2. Okay, so it falls under the first case, isn't it? This case. Okay, here M value is greater than 1. So M can be 2, N can be 3, M can be 4. Okay, if M is 5, it is still greater than 1. If M is 3, still greater than 1. If M is 1, then it is equal to 1. If M is 0.2, then it is less than 1. If M is 3, it is here. So we are getting M as 2. That means it is under this category. So here M is greater than 1. The value of M is greater than 1. Alright, are you following? So when M is greater than 1, the image is enlarged. So what do you understand? When M is greater than 1, if this condition is satisfied, then what do we understand? We understand that the image is enlarged. Okay, these are the things that you need to learn. Okay, by the value of M, if the value of M happens to be greater than 1, then understand that the image is enlarged, which is validated by this ray diagram. See, check out the object size and check out the image size. The image size is bigger. Okay, the image is bigger. When is it happening? This is happening when the value of M is greater than 1. Let's go back here now. Okay, here value of M is less than 1. Value of M is less than 1. So here image will be smaller. Image will be smaller. See, compare the size of the object and the size of the image. Image is much smaller, is it not? So here in this case, when this case happens, then here you can conclude that image is smaller. Okay, image is smaller. Are we clear? Okay, and then one more case. Okay, let's take one more case. This is the principal axis. Sorry, it's ball. Principal axis is this line. Okay, then let us take this as the focus. Same measurement, you take it, keep it, make it your C. Let the object stand here. Take one ray, let it travel parallel. Ray traveling parallel passes through focus. Then take another ray. Okay, and no, this figure is coming out to be wrong. Let me do some slight modification here. Okay, because I want to show you that other one. So in this case, yes, let's do like this. Okay, so here the image is here now. Yes. Okay, like I said, even teachers can make mistake. Okay, so you need to practice a lot. Now, yes. Now, let me just draw nicely. All right. Now see, let us do the calculation here. So M formula is HI by HO. Okay. This is HO. Okay, class. This is HO. HO. Now HO means height of the image. Height of the object. Sorry, HO is height of the object. So let's keep the height of the object to be say 5 centimeter. Then here the object height and the image height is same. So HI will also be how much? Will also be 5 centimeter. Okay. So HI will also be 5 centimeter. So M is equal to HI is 5 centimeter. No need to write the centimeters and all that. And HO is also 5. Okay. Do the convert in the lowest term. 5 ones are 5. 5 ones are 5. So M you're getting as 1. M value you're getting as 1. M value you're getting as 1. It is one of the cases now. M value you're getting as 1. So we are in this category. So when we get M equal to 1, let us discuss in terms of image. If you get M to be 1, how is the image? The image is exactly of the same size as the object. Yes or no? Image is 5 centimeter. Object is 5 centimeter. Same size or not? Same size, na? So if when we get M value to be 1, the image size and the object size are same. So you will write same size as object. So here in this case you will write image size same as object. All right, so this is what you will write. Okay. Now another one is here. Whenever we get, now let us discuss magnification in terms of sign. Okay, so when we get positive magnification, so one more, let us draw one more. Let me use this red marker. So this is almost over now, so let me just write here another detail for you. So when we get m value to be positive, so when m is equal to positive, then what is it? When m is equal to positive, remember the image is virtual and erect. So virtual and means plus, erect. Okay, and when m is equal to negative, what is it? We will get real plus inverted. Okay, are you having doubts? Okay, then let's do some examples like which we did here. Now, okay, now let me erase this one and let us check whether this is correct or not. Let us try to understand this. So we will let go of these things now. Okay, now we will start with this one. Okay, now this is okay, this is the object. So the object is here, the pole is here, measurement will be done from here to here. Okay, let's say the object distance. Okay, let's say the object distance is, how much should we take? From here to here, if we use from here to here to be 10, then from here to here is 10, so this is 10, then from here to here another 10. Okay, so this is from here to here, that makes 20. From here to here 10, another from here to here 10. Okay, then this is half of it, so let's say this is 25. So let's take the object distance to be 25. So u will be 25. Okay, 25 centimeter. All right, 25 centimeter. Now object distance will always be negative, so remember to put minus. Remember, these are our assumed value. Okay, just to check what these things mean. Okay, so how I'm doing, I am first taking the focal length, so I am taking this to be 10. If this is 10, then remember how I drew the center of curvature, na? I took the same measurement here. So from here to here is 10. If I go back like this, then another 10. So from here to here becomes 20. Then this is in between this and this, in between this. So I'm assuming it to be 5. Okay, so this will be 25. So 25. Okay, then let us find this now. Let us find this. From here to here we are taking it to be 10, and this is exactly between this and this, so it will be 10 plus 5. Okay, so from here to here it will be 5, because from here to here is 10, it's in the exact middle, so it will be 5. So v will be how much? V is how much? From here to here is 10 plus 5, 15. It will be 15 centimeter. All right, 15 centimeter. Now the image is here, so while measuring the image we will be going like this. Light direction is going like this, light is going like this, the direction of light, and my direction is opposite, so again I'm getting negative value. Okay, because my direction is opposite to the direction of light. So now m is equal to, formula is, what is the formula of m? M is equal to minus v by u. This was one of the formulas for magnification. Okay, where we need to use the image distance and the object distance. So m equal to, minus from the formula will remain, and v, the value of v itself has minus in it, so don't forget to put that minus. Okay, and then u value also has minus in it. Okay, so you can cancel this one and this one. Okay, so what are you left? You're left with minus 15 by 25. Excuse me. So if you cut this, 5 3 is 15, 5 5 is 25. So minus 3 by 5. Okay, now forget about these values. Okay, forget about these values. About these values we have already discussed in this. So here our focus is primarily on the sign. So what are we getting? we are getting a negative value. Okay, like I said, forget about these things. What matters is that the answer of m you are getting as negative now. Okay, that is our primary concern here. So you are getting a negative value. You are getting a negative answer for magnification. Okay, so when m is negative, okay, when m value is negative, what should we understand? That it is real and inverted. Let's check. Is this a real and inverted case? Class, is this a real and inverted case? The answer is yes. This is a real and inverted case. Okay, this is a real and inverted case. Look at the image. Is it inverted or not? Yes, is it not? This is inverted. Okay, the image is inverted. So, and the rays are actually meeting. The rays are actually meeting. So this is a real and an inverted case. So remember, if you get magnification value to be minus, to be negative, then you can conclude that the image is real, that the nature is real, and then the image is inverted. So you are getting yourself a real and inverted image. So this has been checked, and it has been confirmed that this is correct. Then without any doubt, even this will be correct. All right, so even this will be correct. Got it? So remember that both of these will stand correct. Okay, we have checked for this one. Okay, this one this one, should we check or not? Okay, let us try to check for this one also then. So let us check whether this stands correct or not. So let us erase this one. Now for this one, this is virtual and erect. Okay, so let us take another one. Let me erase this one also. Now, so we have to get virtual and erect. All right, now for this, which case will I draw? Okay, let me draw case 5 or case 6. Okay, so let me draw case 6. So case 6 is still concave. This is the mirror. Then let this be the focus. Okay, in case 6, the object is standing between focus and pole. All right, remember this one. So this is focus. To double of that will give me my center of curvature. Okay, is it exactly same or not? If it is not same, the diagram doesn't come out properly. So let's draw now. First ray goes parallel. Parallel ray passes through focus. So be careful. Okay, be careful to draw properly. So this is the first ray. Okay, second ray I'll make it pass through pole. So the second ray will pass through pole. So let's try to get a precise one. Okay, then the angle which it makes should be equal. So let us try to get equal angle. Okay, let's say this is the one. Okay, demonstration only. So let's say it's equal. Okay, now the rays are not gonna meet here, so we have to trace it back. So we are tracing it back all the way. Okay, all the way. Okay, I hope I'm not out of the screen. Okay, so you are getting the image somewhere here. Okay, so we have to extend this one, and we're getting the image here. This is our image. Okay, class, this is our image. Okay, the image is not from this side. Here, look at the rays. The reflected rays are not gonna meet. They're meeting here on the right side. Okay, so arrows are very important. If you don't write the arrows, you will lose mark. So let's write the arrows also. Okay, now we are going to check this statement. Okay, so we know the formula. It's going to be minus v by u. So we need v and u. Okay, let us give values to our u and v. So this is the object here. Measurement will start from here. So direction of light, again, it is like this. Direction of light is like this. So we are measuring like this. We are measuring object. I already told you that object is always negative. So by default, u will always be negative. Okay, whatever value let it be. So what value should we take? Let's take the value of let's say from here to here is focus. So let's say focus is 10. So this happens to be exactly in between focus and pole. So we can take this to be 5. So let's just take 5 centimeter. Now if we take this to be 5, then if this is 10, then if we go like this 10. Okay, so this is almost focus, so 10. Then this will be again 15. Okay, because this will be another 10. So 10, 10. So 10, 10. But this is not the entire 10. We need only the middle of this one. So for the full set, 10, half, 5, 15. So VU again, we can say it's 15. Okay, now it is 15 centimeter. Wait for a moment, stop for a moment, check. Now we are measuring, this is the image, okay, we are measuring image distance. Now you will start measuring from here. So you are going like this, in this direction. Check out your direction with respect to the direction of light. Is your direction and the direction of light equal or opposite? They are equal, na? If they are equal, that means you get a positive. So the value of V here is positive. Alright, how positive? Here we are getting negative, there we are getting positive. How? Here we are getting negative because the image is from here, is not? Pole is here, image is here. You are moving like this. Your direction of movement with respect to the direction of light is opposite, so you will get negative. That is the rule. But here, direction of light is like this, from left to right, and you are also moving from left to right because the image is here. You are going here. This is the image here. You are starting from here. You are going like this. So your direction and the direction of light is along. So this time you will get positive. Okay. Now let's use the formula. M is equal to minus V by U. So minus from the formula V is positive, so we have 15, and U is minus 5. So minus cancels. 5 ones are 5, 5 3s are 15. So the answer of M is 3. Okay, now forget about this value 3. Okay, our focus is what sign are we getting? Are we getting negative? No negative. That means this is positive. Okay, this is all I want. Okay, I want this. My focus is on the plus sign, not on this value. Okay, so I'm getting a positive sign for magnification. If I get a positive magnification value, what should it be? It should be a virtual and erect case. Now let's check. Is it virtual and is it erect? Let's answer this. Is it virtual? Is this a virtual image? The answer is yes. Okay, this is a virtual image. Okay, because the rays, they do not meet. Okay, they do not meet, but then we trace them back and then they appear to meet, and see they are meeting behind the mirror. So this is a virtual case. Okay, now virtual images are always erect. Is the image erect? Yes, the image is erect. You can see it's an erect image. Okay, it is an erect image. So remember this, whenever you get magnification positive, then it's a virtual and erect case. Whenever you get magnification negative, it's a real and inverted case. Okay, this condition works for mirror only. Okay, remember, for lens things will change, but for mirrors, okay, these conditions will work. So for mirrors, if you get M positive, it is virtual and erect. For mirrors, if you get M negative, it will be real and inverted. So I hope you understood something. Okay, so we will end the class from here. Thank you for joining in and watching. Okay, continue watching, keep supporting, and then God bless you all.